Hello friends, welcome back to the channel. We've just started this video with a brand new project. Today we are working on a voltage diverter circuit. In this video you'll see how we built it and how we tested it using a fan. The fan runs really smoothly, which shows our circuit is working perfectly. So watch the video till the end and let's get started with this project. The moment we connect the fan wires, it starts running smoothly at an impressive speed. So friends, stay with us and let's see what exciting results come next in the video. Designed directly to their website. Even beginners can get their circuits made like a pro, without any hassle. I've personally ordered multiple PCBs from them, and every single time, the quality has been outstanding: neat finish, accurate solder mask, and fast delivery right at my doorstep. So friends, we've picked up a few essential components that you can see right here. With the help of a PCB stand, we securely hold the board in place and then carefully install all the components one by one to build the complete circuit properly. Now, our PCB is firmly mounted and we're ready to install all the components. First, we add the charging connector and then connect the two terminals to complete this stage of the setup. Next, we install the wire connectors. A total of 8 connectors are placed here, ensuring clean connections and a strong, reliable setup for the entire circuit. Now we're installing a bright red LED light that gives a clean, sharp glow, making the circuit look more attractive and easy to monitor. After this, we add 2 resistors to control the current, protect the LEDs and keep the circuit running safely. Now that all the components are installed, let's move ahead and see what happens next in the video. Let's imagine we are working on a project, say designing a battery management system product with enclosure and all. Sounds simple, right? Until we have component delays, board fitting issues, thermal problems or safety compliance. That's where Altium Develop saves the day. In this, we can capture all the requirements in one environment so everyone sees them. Then its BOM portal helps to check the selected component availability, pricing and life cycle status. For traditional schematic and PCB design, Altium Designer is already there. But the Altium Develop helps with MCAD, ECAD code design for mechanical engineers to check the PCB fitting. When the design is done, we get a platform where team members review and give feedback on contexts like safety and pin maps, etc. After review is done, Altium Develop generates release packages with up-to-date BOM and design documents. And it preserves version history so we know who approved what and when. Finally, Altium Develop saves all of the data like version history to evolve the product during production. Our life gets easier with Altium Develop. It is faster, safer and smarter. If you want to develop a full electronics product, you can check the link in the description to know more about it. Now it's time for soldering. One of the most important steps in building any electronic project. Using the soldering iron, I carefully join each component to the circuit board, making sure every connection is strong and precise. Soldering isn't just about connecting parts, it's about ensuring the circuit works reliably and safely. I take my time checking each joint, applying just the right amount of solder, and making sure there are no cold joints or loose connections. A clean and neat soldering job makes the entire project look professional and guarantees it functions perfectly. And here we have the JLCPCB board. Its quality is truly unmatched, something you just can't compare. Now I'm connecting the adapter to the board. All the wires are now securely connected and ready to go. And using a multimeter, I carefully monitor the voltage as it rises. Step by step, I attach the wires to their connectors, making sure every connection is secure and accurate. Watching the voltage increase in real time gives a clear idea that everything is working perfectly. This process ensures not only that the board functions correctly, but also that all components are safe and stable before moving to the next step. So friends, our circuit is working perfectly here. I've carefully tested every single component to make sure everything is functioning just right. Now I'm installing the fan that you saw at the beginning of the video. Using wire connectors, I carefully connect the fan wires to the circuit. Now, I carefully insert the wires into the connectors, making sure to work with full attention and safety. After placing the wires properly, I use a screwdriver to tighten the screws firmly. This step is very important because it prevents any loose connections during operation. A tight and secure connection ensures stable performance and protects the circuit from damage. As you can see, everything is now well fixed and ready for smooth and reliable use. Would you like me to help you draft a set of safety precautions or a maintenance checklist for this type of electrical work? Here, all the wires are now fully connected. Next, I plug in the adapter, and as soon as it's connected, the circuit starts working perfectly. You can see the fan immediately begin to rotate, which clearly shows that everything is functioning as expected. This confirms that our wiring and connections are correct, and the circuit is operating smoothly and safely. The circuit worked perfectly with the adapter. Now let's see how it performs using the battery. And as soon as it's connected, now I connect the battery to the circuit. You can see the fan running perfectly, which proves that the circuit operates correctly even on battery power. The system starts working smoothly. So friends, let me know in the comments how you like this video and share your new ideas with me. Your suggestions really help and motivate me to create better projects. I truly appreciate all the love and support you give. I'll see you in the next video. Until then, goodbye friends and take care.